Okay, in this video we're going to check out really specifically congruent triangles, but we want to check out different ways that we can show that two triangles are congruent. So first things first, when we say congruent, we're talking about two shapes that are exactly the same in dimension. So the first thing to notice is specifically, congruent means that corresponding angles and sides are exactly the same. They are congruent. So all of the angles and all of the sides are exactly the same. What we want to make sure that we understand is how to match up congruent angles and congruent sides. So an angle that's in the same relative spot from one triangle to the next is what we call a corresponding angle. So angle C here is kind of like the skinny angle, the smallest angle in this triangle. And if these two triangles are congruent, then that angle C would correspond to angle F in this other triangle. So we call those corresponding angles, and we want to make sure that that we understand how to identify corresponding angles. Okay. So first thing is, if you're given a diagram, you can identify those based on those tick marks or the arc marks. So for angles, we've got one arc mark here that corresponds with this angle right here, and one arc mark shows that they're congruent. Angle B is going to correspond with angle E in this other triangle, and angle A corresponds with angle D. So the first thing to notice is that we do have corresponding angles that are congruent, and we can identify those by the arc marks. And then we can also similarly say that angle BC is congruent to angle E, or I'm sorry, side BC is congruent to side EF, side AC is congruent to side DF, and side AB is congruent to side DE. So more generally, what we write is that triangle ABC is congruent to this other triangle DEF. And now the thing that I want to point out is we want to make sure that we write this in a way that we can identify corresponding angles based on the statement of congruence. So the statement that I'm writing is a statement of congruence, and I want to make sure that if I have A in the first slot, that angle matches up with whatever I have in the first slot of the second triangle that corresponds to angle A. So we said angle A up here corresponds to angle D, angle B corresponds to angle E, and angle C corresponds to angle F. And so I want to make sure that I write these in a way that the corresponding angles and sides, for that matter, match up. So if I look down here, I look at AB, that side should match up with the first two entries here, DE, and we can see that it does based on those tick marks. So really in the big picture, we can look at this statement of congruence and we can identify corresponding parts based on the order that they're written. Okay, so that's really the big thing to take away from this. So two triangles in this case that are congruent, we've got a statement of congruence that really just lists those parts in order that correspond to one another. So the second thing to recognize from this is that they are congruent if we can show that angles and sides are congruent, and that means all of the angles and all of the sides. So if we can show that all three angles are congruent and all three sides are congruent, then we know we've got a congruent triangle. So let's check out a way that we can do this, or a specific example in which we can do this. And I want you to pay attention to the way that this proof is laid out. So notice, number one, that this is a triangle congruence proof. We're trying to prove that two triangles are congruent. So in order to do that, any proof that we do starts with the let statement, and the let statements for these are relatively simple. A lot of times it's just going to be let the diagram be given. And on that diagram, we're going to use the information that we're given up here to label. So first things first, angle R is, that shouldn't be angle R, that's just R. R is the midpoint of PM, okay? So R right here, this intersection, is the midpoint of PM, which means that it chops it in half. And so I have two congruent pieces. I want to make sure that I label those two congruent pieces there. Second one is that PQ is congruent to MN. So PQ right here, congruent to MN. Let's go ahead and make sure that we label that on our diagram. And QR is congruent to NR. QR is congruent to NR. So again, we can say let the diagram be given because I've taken all the given information, labeled my diagram, and that's the start of our proof. Okay, so if we want to prove that these two triangles are congruent, then we need to lay this out in a way that's going to show that all three sides are congruent and all three angles are congruent. All right, so let's check this out. First side, we're going to say PR is congruent to MR. And the reason that we can make that statement is because of this given information up here. R is the midpoint. So we would say definition of midpoint. So the midpoint is something that chops a segment into two congruent parts. Therefore, the two parts are congruent. The thing to notice about this is we have a congruent statement, and we also have a reason that we can make that congruent statement. All right, so notice as we go through this, we're going to make these two statements for everything. The second side argument is that PQ is congruent to MN. And the reason that we can make that statement is because it was given. That gave us that information. Okay. Third one is QR is congruent to NR. And again, that was given information. So a lot of times you're just going to be given this information flat out, that particular segments, corresponding segments, or corresponding angles are congruent. Okay, so we've gone through the process, showed that all three of our sides, all three pairs of corresponding sides are congruent. So let's check out the corresponding angles. We can look at, let's start with angle Q, and we need to somehow reason that it's congruent to angle N. Well, if you check out what's going on here, my original given information, I've got parallel lines for PQ and MN. Those are both parallel. So if I look at the relationship between this angle and this angle, angle Q is congruent to angle N. And I can say that because those are alternate interior. I've got parallel lines cut by this transversal NQ, which creates alternate interior angles. And I know that alternate interior angles are congruent. So that's my first line of reasoning and my first pair of congruent corresponding angles. The second part is based on this, the information that I was given on the diagram. I know that angle P is equal to 90 degrees, and that's also equal to angle M. And therefore, those are congruent, and that was given information. So again, statement of congruence and a reason that you can make that statement always included for each one of these arguments. Last angle argument is angle PQR. Remember, make sure you specify, don't just say angle R. There are four different angles here that angle R is involved in, so let's make sure we use three different letters to specify that. We know that PQR, angle PQR is congruent to angle MRN. Oops. And the reason that I can say that is because these are vertical angles, and vertical angles are congruent. Okay, so I've got my three side arguments, my three angle arguments, and then the last thing is because I just showed all of those work and the reasons for those, therefore I know that these two triangles, PQR and MNR, are congruent. So again, long drawn out process, and we'll look at shortcuts here in a second, but what I want you to understand is the structure of this argument. Number one, you always have a let statement. Number two, for any argument that you're giving, you have the argument of congruence, or the statement of congruence, and why that statement of congruence is true. Sometimes it might just be given information. Other times you need to explain a little bit further. And then we always have a conclusion in order to solidify the process that we just went through and why we just went through that process. Okay, so the nice thing about this is we don't always need all of this information. So our definition of congruence is that all three pairs of corresponding sides are congruent, and all three angles or pairs of angles corresponding angles are congruent, but we don't always need all of this information. So we do have some shortcuts in order to kind of minimize this process and quicken this process. The first shortcut that we're going to look at is side, side, side. And so what this says is if you have two different triangles and all three pairs of corresponding sides are congruent, there's no way to create two different triangles if we know that all three pairs match up. Okay, so here they're telling you that AC is congruent to DE. They're telling you that AB is congruent to DF, and BC is congruent to EF. And so essentially, again, like I said, if you know that all three pairs of corresponding sides match up and they're congruent, they have the same length, then you're always going to create the same exact triangle. It might be oriented differently, like you see these two, but ultimately they are the same exact triangle. So our first shortcut is if we can just show that all three sides are congruent, then we know that the triangles are congruent. And so let's look at a quick example of how to do that. Again, the structure of these arguments or these proofs is pretty similar to what we looked at before. So the first thing is we need a let statement. So let the diagram be given. Let the diagram be given. We see that we've got a couple different things going on. Number one, PQ is congruent to PS. QR is also congruent to SR. And then we've got to find a way to make a third side argument. So PQ congruent to PS. And the reason that I can make that statement is it's given information. It was given right on my diagram. Okay. Second one is QR is congruent to its corresponding side is SR. And again, that was given information. That's info that we started with. The third argument is there are a couple different ways that you can argue this. The simplest way to argue this is that PR, and just make the statement that it's equal to itself, or just say PR is a shared side, meaning that the same exact side is used in both of these triangles, so it has to be congruent to itself. The other way to argue this, and you don't have to give both of these arguments, is that PR is congruent to PR by the reflexive property, what we call the reflexive property. So the reflexive property really just says that something is congruent to itself. I like the shared side argument because it makes a little bit more sense, puts it into our own words. But these two essentially are the same exact argument. So we've got our three sides. We've proven that all three pairs of corresponding sides are congruent. And so now we need a conclusion. That's our first shortcut. If we can do that, then we can say that the triangles are congruent. So therefore, triangle PQR is congruent to triangle PSR. And this is really the only thing in addition. If we use a shortcut, we want to make sure we state the shortcut that we used. So we just say these triangles are congruent by SSS shortcut. Okay, so let's check out the second one here. And before we actually check out the second shortcut, we want to make sure that we understand the definition of what an included angle is. So an included angle is an angle formed by two adjacent sides, or in other words, two sides that are next to one another. They are next to. The technical definition is that they share a vertex. So they have the same vertex. That's the technical definition of adjacent sides. At any rate, we've got two angles, an included angle is an angle formed by two adjacent sides of a polygon. So for example, angle B right here, this is angle B. Angle B is formed by this side and also this side. Therefore, we say that angle B is the included angle of sides AB and BC because it is formed by those two coming together and forming a vertex. Alternatively, if we look at angle A, so this angle right here, angle A is the included angle of AB and AC. So again, the angle, if you have two of the sides coming together, the angle is kind of in between those sides, or it is formed by those two sides coming together and forming a vertex. We call it an included angle. So why this is important is for our next shortcut. So our next shortcut is the side angle side shortcut. And so what this says is if two sides and the included angle, and this is the important part of what we just talked about, two sides and the included angle, or in other words, the angle that is in between them of one triangle are congruent to two sides and the included angle of another, then the triangles have to be congruent. So in other words, if I've got two sides and the angle that's in between them, and they match up for two separate triangles, so they are congruent, these three pieces are congruent in two separate triangles, then I know the triangles have to be the same. They have to be the exact same triangles. Okay, so in this, the important thing is you look at the order in which these things are given. So the angle's got to be in between the two sides, and that's the way that we're going to argue this as well. So here's a quick example of using SAS congruence in order to prove that two triangles are congruent. Okay, so here's the given information. Let's use that given information to prove that these two triangles up here are congruent. So first things first, let the diagram be given. Okay, so essentially, if you step back and look at what we have right here, we've got a perpendicular bisector. PQ is chopping this opposite side in half, and it's also perpendicular to the opposite side. But what we want to do is we want to show that the two triangles are congruent. The two triangles that are created by this perpendicular bisector are congruent. We're going to use SAS to do it. So the first thing I want you to notice is we always argue in order. So SAS is always in this order. If we're going to use the SAS shortcut, the angle has to be the included angle. Must be the included angle, or the angle that's in between the two sides that you argue down here. All right, so let's check this out. So if we go over and look at this diagram here, my first side argument is just going to be the very simple one that's given. So I know that RQ is congruent to SQ, and the reason I know that is that's given information. Okay. The next thing that I'm given here, or that I'm not given, is, or that I need to use, is this given information that this is 90, but I also need to reason that this is 90 as well. And so the first thing I'm going to do is I'm going to give the angle argument. So angle RQP is congruent to angle SQP. And the reason that I'm going to give this is, the reason I'm going to give these, or attach to this argument, is that these two are right angles that form a linear pair. And so if they're right angles and they form a linear pair, they've got to be supplementary, and therefore this other angle has to be supplementary. So the big argument here is that these form a line, and we know that lines have degree measures of 180. One of them's 90, so the other's got to be 90. This explanation is enough for me. Okay, so that's our angle argument, and the thing that I want you to understand is our next argument is going to be for this side right here, PQ. And the argument comes from the fact that it's the same, it's used in both of these triangles, and so therefore it's a shared side. Okay, and the biggest thing about this proof here is that the angle is in between the two sides. So if we look at, here's our first angle, or our first side argument, RQ. Our second side argument is PQ. The angle is the included angle, and the argument is given in that order. So these are really important. This is really the important thing in distinguishing this, because we're going to have some more kind of combinations of shortcuts that we can use. But for SAS, the included angle must be used. It must be an included angle. So our last piece here is our therefore, our conclusion statement. So therefore, by SAS shortcut, we know that triangle PQR is congruent to triangle PSR.